So hello once again. This is Roger Koch Barr for the Bioelectricity course. We are in week 3, and in the second half of week 3, where we are now, I thought we would work on the question of channel behavior. Now, channels are the structure in the membrane that allow ions to move through. They are very tiny. Nonetheless, it is possible to isolate a single channel. Let me tell you how that can be done. It is quite something. So, as you know, the art of glass blowing is very, very highly established. People have been working on it for quite a long time. And the true craftsmen of the field are really superior. Suppose one of the craftsmen of the field takes a glass tube. So here's a glass tube. Here. Here. Here's the tube. Suppose the craftsman holds the tube in his hands, left and right, and suppose the craftsman holds the tube over a very hot flame. I'm drawing my flame here red and blue, but as you know, when you look at such flames as if from a Bunsen burner, they're more like yellow or even white. So the craftsman holds the glass tube over the flame and pulls it apart. But because the tube has been heated and the material in the tube is now very soft, the glass flows. It doesn't just break, but it flows. And in fact, it necks down in this region. It necks down narrower and narrower. And in the hands of an expert, it can become exceedingly small before it finally breaks. So after a long time, with careful pulling, well, not such a long time, it's pulled quickly, but after a long stretch, the glass will break, and that point that I marked will be exceedingly small. Maybe just a micron or so, or maybe even less than that. If you make such a tube, if a craftsman makes such a tube, and then if one makes use of the tube, you can do the following thing. First, you fill the tube with water. Well, not exactly water, but salt water, a solution that is similar to the composition of real tissue. Suppose then you take the tube and you suck on it a little bit. You put the end right down on the tissue, right there. Put the end of the tip right down on the membrane, and then up here at the top, you apply suction. I've even heard of people doing this by sucking on it with their mouth. That's not such a good idea. A much better way to do it is to suck on it with some kind of apparatus that can apply a gentle but very steady suction. When that happens, the suction will pull the tissue back up into the tube, right there, and you will get a little teeny tiny piece of membrane right in the end of that tube. So now if you lift the pipette away from the tissue carefully, you can break off that little portion of the membrane that's sucked up into the pipette from the rest of the larger membrane surface. Go over into a different chamber and perform an experiment. So in this now new chamber, we insert the pipette. Here's the pipette, right here. Pipette still has the membrane attached, right there. We have added some electrical apparatus. So we see meter V1, meter V2, a resistor. Then the wire comes over from the voltmeter, comes over down into the solution and into a metal plate on this side. And somewhat similarly, it comes around down into the solution and up to a metal plate on this side. And now this apparatus can be used to pass a current, pass a stimulus current through that little tiny patch of tissue, or alternatively, to impress a voltage on that little segment of tissue. Suppose what is done is that we impress a voltage on the tissue and then measure the current. That can be done by using this meter V1 and V2 and this resistor as a device to measure the current. So what we're going to do is we're going to take our meters and impress a voltage, and the voltage as a function of time is going to go like this. It's going to be low, it's going to jump up, and then it's going to be high. And let's suppose that the kind of tissue that we have isolated has been a potassium channel, a channel in the membrane that is selective for potassium. What happens? Well, you won't find out in this segment, but if you'll come back in the next segment, you'll find out what happens when you do that. It is not what you'd expect.